Okay, so what we're looking at now is the experiment that handles the iron tablets, which is iron sulfate, rather than the ammonium iron sulfate. So the number of tablets used was about 5. The mass of the iron tablets, so what you weighed, this could be different or slightly different depending on what you weighed, but it should be around 2.1 grams. The volume of the iron sulfate that we pipetted was 25 centimeters cubed, as always, from our pipette. The average titer should have been around 10 to 11. Okay, so whatever you find. Take the two titers that are around 0.1 in the difference, add them together and divide it by 2. That'll give you your average titer of the potassium permanganate. Okay? Now this we found out from the last experiment. So whatever your molarity in the previous experiment was, you can put this in here. I have written in 0.017 and you should get around 0.01 something. Okay, so we can stick with that. The calculations from here on in might be slightly different depending on your average titer and the molarity that you're using. So we're coming back to our original formula. Fill in your average titer, your molarity, and then from this equation up here, we can say there's an imaginary 1 there. So 1 mole of KMnO4 will react with 5 moles of iron. So hence why there's 1 mole for the oxidizing agent, 5 for the reducing agent. Then the volume of the reducing agent was 25 because that's what we pipetted. So moving back over here. Now, using our formula as usual, filling in everything that we have, molarity, volume, the number of moles, molarity, volume, number of moles. We worked out the molarity of the reducing agent, which is the iron sulfate, to be 0.0345 moles per litre. You should get around that result, even if we have a different molarity and a different titer. We should be aiming for something around that. Okay, so because we didn't have a full litre, that's that question done, because it's just asking you the molarity of the Fe2. That's that done. But there's not actually enough space down here for you to do your full workings out, so I've used the room up here. So let's just see what it's asking you. The molarity of the Fe2 solution per litre, I'm going to presume, because it says grams per litre here. So we can write in 0.035, which is the rounded version of this. Put that in. To get it into grams per litre, all we have to do is look at the mass number of iron, which is 56. Okay, you can see that there. I'm multiplying it by 56. And I get 1.96 grams of iron per litre. So that's what you should have written down there. It's not probably the exact numbers, but that method. Taking your molarity and multiplying it by the molecular mass of iron. Now for the grams of FeSO4, you're going to take the molarity and multiply it by the molecular mass of FeSO4. So that should work out as 152. So we're taking it again, multiplying it by 152, and we should get something around 5.32 grams per litre. Okay. Number of grams of FeSO4 per tablet. So this isn't per litre anymore, it's per tablet, and it's jumping from very generic, straight into what's in it each tablet. So this is why I had to go back up. We didn't have a full litre, we had 250. So I'm not diluting it or anything, I just want to see how many exact moles do I have in my 250. 250 centimeters cubed is a quarter of a litre. So I'm taking my number of moles per litre, dividing it by 4, and I'll get exactly how many moles I had of the iron sulfate, which was the reducing agent, in my 250 centimeters cubed. So we see that note there, we didn't have a full litre, only 250. So that's how many moles of the iron sulfate was in the 250. Okay, once we work that out, we can find how many grams of that was in the 250. Okay, so that's what I'm doing over here. 0.00875, which is my actual number of moles in the 250, times the molecular weight of the iron sulfate, and I got 1.33 grams of iron sulfate in the 250 centimeter cubed volumetric flask. Okay, so it's asking me how many grams of iron sulfate per tablet. So I have 5 tablets, so I take that measurement and divide it by 5. That'll give me 0.266 grams of iron sulfate per tablet. Okay, again, these might be slightly different if you get a different molarity. All from up here, it's being all affected. Okay, so I'm looking for a roundabout results here. Okay, so moving on, it says the percentage of iron in all of this iron sulfate is this. What they've done is they've taken the molecular mass of iron and put it over the molecular mass of the whole iron sulfate. And they found out that the iron makes up 36.84% of the iron sulfate. Okay, therefore the mass of iron in each tablet is 36.84% by the number of grams of FeSO4. Okay, so that makes sense. If this is all of the FeSO4, then only less than this should be the amount of iron per tablet. So it's taking that weight of the amount of FeSO4 in the tablet and multiplying it by my percentage, I get 0.098 grams of Fe2 plus in each tablet. Okay. Now it's asking for the percentage of iron in the iron tablet. So I have how much iron is in the tablet, but it's not as a percentage. So I need to find the actual weight of the full thing of one tablet. So if we look back here, we do have the weight of all of the iron tablets here, 2.1 or whatever you got. So what I've done up here in the corner is taken all of my weight from the tablets, divided by 5, and each red tablet should weigh 0.42 grams on average. Okay, so I need to now put the weight that I know for sure of iron in each tablet over the full weight of the tablet. I'll get 0.23 if I just put this in. If I multiply it by 100 to get a percentage, I'll get 23% of iron in each tablet. Okay, so that's that done. We've done all of that. It's just a bit messy and it's making you jump a good bit to get to here. So make sure that you realize that we don't have the full amount of moles that it says up here in a litre. We only have 250. So that's that step that's really important here. Okay, observations as usual is the colour change. It goes from colourless to pink. And I actually haven't finished this. It took about 10.15 centimetres cubed of KMnO4 to fully oxidise. And you can say the iron tablets. And from this I have found, number 1, the molarity of the reducing agent. The molarity of, the number of grams of iron sulfate per tablet and the percentage of iron per tablet. Okay, lots of these different type of questions can be asked in an exam situation. So you'll need to be very comfortable moving between things and finding different percentages of different parts of the tablet. Okay, so just keep that in mind.